Hi, Ruth Adusu here. The purpose of this video is to show you how to use Adusu Algebra when you first introduce algebra to Year 7. So when you first start with algebra with Year 7, I give each student a kit, or there is a double set available, so one between two, and I just give them a minute or two to have a look at the pieces, lots of colours and shapes which they want to look at and build patterns with, so I give them a minute or two to do that. Down the front though, the main pieces, we have X's, we have Y's and we have 1's. Across the middle are blank pieces to be used as spares, or we can write other letters on them with the markers provided, and then there's some more pieces up the back. On the inside of the lid is a little template showing you where all the pieces belong and how many of each there are. As well as the kit, each student gets a plastic covered worksheet with an equal sign on one side for equations and blank coloured piece of paper on the other side for expressions. This goes on their desk, and when I ask them to build something, it's easy to look around the classroom and see clearly on this plastic sheet whether the students have done what I've asked them to do or if it's correct. So my first question with the kids using the kit would be something like, build 3 plus 2 for me using the pieces from the kit. Most kids will do that straight away. A couple of kids will say, I can't find a piece that says 3 on it. So I'll say, well, if there's no 3 piece, what else can you use? And so it doesn't usually take long before every kid has something like this in front of them, at which point, once everyone's got it, I'll say, now of course the answer is 5, which we can see just by pushing them together. And then I'll ask them, can you please build 5 using the same pieces or different pieces in a different way to this? And so, of course, what I'm looking for there is that the kids recognise that 1 plus 4 is 5, 4 plus 1 is 5, 2 plus 3 is 5, or we could perhaps have something like 1 plus 1 plus 2 equals 5, and that, in fact, 5 can be expressed in a number of different ways using the same. So after we've discussed different ways of expressing 5, I'll get the students to build something like this. So 4 plus 3, and this time I want to discuss the shape. So all the numbers are on parallelograms, and it doesn't matter if they're positive or negative, they're all parallelograms. Of course, some of them are on a rhombus as well, but these are all the same shape. If they are the same shape, they are allowed to go together, and so that's why we can put those together and get a 7. That applies to the whole kit, and that is going to help with collecting like terms later on. So after we've done addition, of course, we're going to come to subtraction. So asking the kids to build this, I might get that, which is fine, that's an accurate representation of that, but I then ask them, just steer clear of the 5s for now, because we're going to be doing the next thing with that. And so 5 minus 2, using 1s or 2s is a better way to go. With the pluses, we learned if the shapes were the same, they're allowed to go together. And now we're going to learn that if the shapes are the same shape but a different colour, they are going to cancel 1 for 1. And of course we can go back over that a bit closer and say, okay, this is 2, take 2 is 0. So we can take them off the worksheet and we are left with the answer 3. Of course, I've used green for the positive numbers to represent credit and red for the negative numbers to represent debt, so that's another connection to make for them. So in multiplication, building 2 lots of 3, we would expect students to build something like this. So next I check that they've got this concept by getting them to build 3 times 4, which of course would be 3 lots of 4. Same shape, so we're allowed to put them together, and there are 12. Then I'd go to negative numbers and do something like 3 lots of negative 2, and so they can look in their kit for the negative 2's, build 3 groups of negative 2's, and see that of course they have 6 negatives or negative 6. So the next thing we learn of course is division. And if I ask them to build 8 divided by 2, most kids will get 8 greens and split that into 2 groups, and then I point out that we have 4 in each group. You might want to use the word sharing, so this perhaps is lollies being shared between 2 people, or the other one I find helpful is talking about picking teams in the playground, where one team will pick players first and then the other team picks. so that we have a fair distribution of players between the two teams, and then each team ends up with 4 players. So now we know how to use the kit with numbers, now we can get on to letters. And it's quite easy. If I ask them to build x plus 2, they will do that straight away without any trouble. X plus 2, and while they're doing that, I might talk about why we might need an x. This might be 3 adults and 2 children. Another time we might not know how many adults we've got, but we know we've definitely got 2 children. So where the kids have learned how to build algebraic expressions, we can give them a variety of expressions to build, and it's easy to look around the room and see if they're building these. Don't even need to write them down, we're just getting used to the language, the idea and the pieces. Just be very careful with this one. I built this once this way until I got Snickers behind me, so of course I avoid building it that way. I'll always do that. X minus 5, we're just learning how they work, so I'd go with the 5 there. I'm not going to be manipulating the -5. X plus y, of course we've got y shapes, and that's a blank. I've only got 4 x's for me, the students have 8 per student. I've just written an x on that, which will rub off if I want to rub that off. The kids are quite happy with just the blue. I don't need to write an x on it. They are connecting the shape and the colour with the x, that's not a problem. So there's x plus 2y, and this next one I can just change that expression by putting that third piece in. And 3 minus x looks like this. And at that point I might stop and talk about how with the 3 plus 2 we can arrange that different ways. So expressions, we can arrange them however we like. We can move the pieces as much as we like. So 2x plus 3 is the same as 3 plus 2, or that for that matter. And that when we've got minuses though, if we rearrange it, the minus travels with the x on the piece. And that will avoid that problem of kids thinking that that's the same as x take 3. So the rest of this introductory lesson would just be building whatever variety of questions I have time for, but also trying to draw in different ways of expressing the same thing, the notation and the language. So this would be x plus x. It can also be expressed as 2x without the time sign, but remembering that that is 2 lots of x. Of course, kids get confused later on when we introduce x times x, but because that is the x squared shape, the kids don't get confused between addition and multiplication in the same way as I found they have in the past. A question like this, we can go to word questions, the sum of a certain number and 2. So we don't know what the number is, that's one of the reasons we use algebra. And a sum, we're not writing plus, we are literally physically adding the 2 onto the worksheet with the x. The product of an unknown number and 4, so I'm going to use y this time. So product, I need to remind the kids or tell the kids that product means times. So 4 lots of y, and that will just look like that, 4 y's. Easy as that. But of course we often drop the times sign out and just write it as 2x or 4y. When we get to this one here, I show them that x divided by 2 is literally a circle divided into 2 pieces. And so that is our answer there, x over 2. Also, we can express that as half a circle. So the teacher kit doesn't have this one because of the magnet on the back, but the student kit has one piece on one side says x over 2, the other piece says a half x. And that makes a connection that's really important even for senior students, because I find that kids are quite okay integrating something like that, but as soon as you give them something like that, they ask what's the quotient rule for integration. And what I can do is remind them that x over 2 is the same as a half x, and so that is actually just the coefficient of a half and works the same way as what they've done with these questions. And the last examples I'll look at are these. We just built 4y a minute ago, so perhaps what do they think negative 3y would look like? Hopefully they're familiar with the kit now to realise that if there's a negative, there's a shape the same but a different colour with a negative on it. So there's negative 3y. We've done x over 2 before. What does y over 2 look like? And they can find, look through the kit and find the y on 2 piece or the half y piece. Negative y on 3. There it is. We might want to do something a little bit more interesting and get them to build something like 2 minus a third y. There it is. As well as half pieces, we have thirds and quarters, and so it's good to ask the students to build this, see if they can find the right piece to build that expression. Again, give them time rather than showing them the answer too quickly. This is a good one because the kids can build 2 lots of x over 4. They know how to build 4 lots of y. They know how to build 2 lots of x, so this is 2 lots of x over 4. And we can talk about, well, they're the same shape, they can go together, and what does that make? Of course, it's half of an x. This is another good one to see how they're going, and usually quite a few of the kids will realise that that's 2/3 of an x and a minus 1. And of course, we've got these x squared pieces and xy pieces, so that we can build a large variety of expressions. And every piece has the same shape but the opposite colour to represent the negative value. And the student kits have different ways of expressing these. So on the back of this one, I think it's yx, so reminding them that xy, yx are the same piece. So that's how I introduce algebra to Year 7 students. They enjoy using the pieces with the different colours and shapes, and in the meantime you're communicating a lot of information and connections between notation, between reality and between the language of algebra. Thanks for watching this video, and look out for more in the series.